So we've talked about ringing. Let's talk about why ringing is bad. Say you have a signal and it looks like this. There's some ringing there. What if one of these dips? What if one of these dips? And I guess I didn't draw it very well, but let me try drawing it better. Have something like this. What if one of these dips is going to be actually less than the threshold for what constitutes a logic 1? Well, let's say the IC says anything above here is a logic 1, and then it'll also have a threshold for logic 0. This dip means for a brief amount of time, you're no longer at logic 1. And so who knows, maybe this will cause certain signal transmission errors. Maybe you misinterpret what should be a 1 as something else. And so that's sort of the reason why ringing is bad. And then like up here, maybe you apply a voltage to the device that it wasn't designed for on its I/O lines. That could be another issue there. And so that's why ringing is something you want to avoid. So how do you prevent ringing? Well, if you think about what causes ringing, it's the impedance mismatch between the source and the transmission line. So you have, I'm going to call this the source impedance or like source resistance, just going to treat it as resistance. And then you have the characteristic impedance of the transmission line. So how do you prevent this mismatch between these two? Because at this mismatch is where you start getting those re-reflections that sort of rattle around here. If there was no mismatch at this point, then you would have the wave going forward. I guess I erased that. So you have the wave going forward, goes back, and nothing happens because there's nowhere to reflect from if these two were matched. The way you can match them is you put a series resistor here. And this resistor, RT, what you do is RS plus RT is going to be equal to Z naught. And so that way, this combination of these two resistors is just Z naught. So the reflected wave, you have the incident wave going here, and the reflected wave comes back, and it sees an impedance of Z naught, which is the same as what it's been seeing so far. So no reflections there. And so it's just sort of absorbed into the combination of those two resistors. And so that's this is called a source series termination. And there's many other types of terminations you can have, but this is the most common for digital buses. And so this is one way that you can prevent ringing. You just put a resistor on the driver's side that lets you match the source impedance of the driver with the impedance of the transmission line.